Now, once we get logged in, once we identify ourselves and we get authenticated, now we're authorized to do something and we start doing something. We're doing our we're doing our job, we're doing whatever it is that we do on that particular system. When we create something or we establish that communication sessions with another computer, or once we log in, we are starting a session. So every time you sit at a computer, you're starting a session, a local session. You can also start a session if you open up a web browser and you go surf to online shop or online banking or making a reservation. Most any type of web application anymore where you log in, you're establishing some type of session in the background. So session management is what we need to focus on. Now that term is used to describe how a single instance of identification and authentication is going to be applied to resources. So you can kind of think about if you go to a web page, a web application, you go to the home page, right? Their first page, and it tells a little bit about the company or whatever it is you're trying to do, and there's a login box. So we put our credentials in there, username and password usually, PIN maybe. We hit login. It captures that information and takes us to maybe the first page. But do we always just stay on that first page? We may bounce from page to page to page throughout the application. When we do that, is it asking us to log in every time? No, because it's taking the session and it's applying it to resources. It will take a session ID and say, okay, this login credentials belongs with this session ID. So we'll take the session ID and we'll pass it along. All right, we're not necessarily passing your username and password along. We're passing that session ID, all right, because that still ties back to the original logon credentials. So web browsers, they rely on these sessions to manage access to these web applications, usually through cookies. Now, cookies get a bad rap, and yes, they should, and no, they shouldn't, because without them, it would be harder for that session ID to be passed. We'd have to actually pass it in the URL, which could be a security concern as well if that particular web application, say, isn't using any type of encryption. If we don't have SSL or TLS to encrypt that traffic, I can see your session ID in plain text because HTTP traffic is not encrypted. It's plain text. If I have a wire sniffer, I can see your session ID. And then later we're going to talk about an attack called a session hijack. That would be a piece of cake to pull off using that. So web browsers, they rely on that session to pass it from page to page inside of the application. So you don't have to log in every page because that's not very feasible. It's not very user-friendly at all. And you couldn't really get anything done. So that session ID is very important. We want to focus on the management of that ID as a security concern. Now, while session management provides ease of use and flexibility for end users, it is an avenue of attack, like I mentioned, session hijacking. And we're going to talk about that a little bit more at the end of this section. Desktop sessions can be controlled and protected through different means. All right, so not web applications this time. Remember, I said you sit down at your desktop, your laptop, you put in your credentials. That is a local session that you are establishing. Now, those sessions usually don't time out. We can have them time out depending on how the organization is set up, what type of policies you're running. But at your home, all right, you log into your computer at home, you sit down, you come back 3 hours later, and you may still be logged in, and everything's fine. It didn't time you out. Now, we can set those, like web applications. They may have a timeout of 10, 15, 20 minutes. Have you ever been on your banking website or buying something, I don't know, Amazon, eBay, wherever, Walmart, whatever online shopping you do, and the kids are screaming or you have to go away, you get a phone call, something, and you come back and it says, I'm sorry, your session's been timed out due to browser inactivity. Please click here to log in again. Well, it timed you out, and that's a good thing. That's not a bad thing. Sometimes people are like, man, that's frustrating because I was just there. I had to go take care of something. I come back, and now I got to log in and start all over again. but it's there to protect you because that computer, or that web application, I should say, they don't know where you are. They don't know that you're in the comforts of your own home. As far as they know, you may be at work. You may be at a public library. You may be at a kiosk in a hotel. They don't know. So they're trying to protect you. Because when you log in, right, the computer, they don't know. It does not know. Without biometrics, if I put in a username and password, it assumes that that's you. Because you have those credentials. You know what it is. But if you don't have biometrics, it's just saying, okay, well, that's the right username and password. Come on in. Here's what you're authorized to do. And if you log in a web application and you log in on your bank, you go to your bank website and you log in, the bank application thinks that's you, right? Username, password, we're good to go. Everything is fine. So you get up and leave. The bank doesn't know that you're gone. Somebody else sits down and takes over your session. Accidentally or intentionally, maybe they were scoping you out, but the bank website doesn't know any different. The application doesn't know any different, and it will keep on going. So that timeout is there to protect you. Other things we can use on a desktop session are screensavers. Very popular. They've been around for a long time because usually, or used to, I don't know everybody that's watching this video, but you know, we used to have monitors that weren't all nice and flat and neat and only weighed 5 pounds. They used to weigh 15, 20 pounds and be gigantic, bigger than the TVs that we have now as well, right? Those CRTs, right? They had the hard glass on them. They looked like those old 13, 14, 15-inch TVs you could buy, back when we were kids. Huge monitors. Well, they had phosphorus inside of them. And what happens is lasers was actually shooting you in the face. No, lasers were shooting the back of that glass to make the picture, right? To make the different colors, to make it look like that. Well, if you had some type of desktop picture on there, right? And let's say you left for the day and left your monitor on, and that screen stayed there the whole time. It would actually start to burn into the screen. So you would see a lot of ghosting, right? Because it was shooting that image at the back of that screen, at the back of that glass for so long, it finally burnt into the screen. So they said, well, this is a problem. So screensavers were developed for that purpose. Because now after 20 minutes, a screensaver could come on. And that's where it got its name from, saving the screen, right? It would change the screen. We used to have, I don't remember some of the old one, like the pipes, right? The old one, or you could have a marquee going along or have it bouncing around. But it's always making the screen change a little bit so you didn't get that burn in. That's awesome, right? But we can also use screensavers as some type of session management because now, well, back then you could too, but there's a box there that says password protect upon return or something like that. So you can set a screensaver, let's say 10 minutes. So if you're away from your computer and for whatever reason you didn't lock it when you got up, after 10 minutes, the screensaver would kick on. And protecting your screen, which is not such a big deal with the LED and LCD monitors anymore. But as soon as somebody came back and moved the mouse or touched the keyboard to get the screensaver to go away, it pops up a little box and asks for the password. And if you don't know the screensaver password, you can't get in. If you do, if your password was compromised, I could get in and see what you were doing. Maybe you left some confidential information on there. I hope not, but it happens, right? Now, by the way, the password that you set for the screensaver is not necessarily the password for your login credentials. It could be something different. You set that when you go in there and turn that on because it will say set password. You hit it and you can set a password in there. We can have automatic logouts. Great thing. Let's say you log in with something that you have. Let's say a smart card, right? You have to put it in the computer. Sometimes it's on the keyboard. Sometimes you have a separate card reader. My laptop has it in the side, right? So I put my card in, and if I get up from my desk, I'm supposed to take that card with me, right? Because that's my ID card. That's my security badge. That's my smart card. It has everything that I need. My private keys, my certificates. I need to keep that on my person most of the time, if not all the time, except maybe when I'm in the comforts of my own home. So I'll pull it out of the computer. As soon as I do, I want an automatic log out. It says, oh, that's it, and it will log me out, or at least lock the screen. And that way when I come back, pop it back in, it's going to ask me for my PIN. I put in my PIN, and then I'm back into my session that I was in. We could have it automatically log you out after a certain amount of time if you don't use smart cards, if you don't have that technology available to you. Not a lot of people have that in their small office or home office, right? I mean, who has card readers where you use that? Not very many. So you could set policies. You could set it up where it will automatically log you out after so many minutes, hour, 2 hours of inactivity. So maybe you say, okay, I want the screensaver to kick on after 5 minutes, and I want it to automatically log me out after an hour of inactivity. Because maybe you got up to do something, you got caught, life caught up with us for a second, and we went outside and started playing kickball with the kids. Well, we were gone for more than an hour, and we got logged out. That's a good thing. All these are good things. They may be somewhat frustrating when we get back, but it's there to protect us. Could have sessions and login limitation on who can log in. How many sessions do we have logged in already, right? You say, well, in a enterprise type setting, you say, well, you're logged in 2 places already. You can't be logged in again, right? Or you've logged in twice. What's going on here? Or 10 times, or 20 times, 30 times. So we could have those limitations. You could have a schedule limitation of when they can log in. Right? You can set up a schedule and say, well, you can only get on this workstation Monday through Friday, 7:30 to 5:30. That's it. So that means you can't log in on Saturday and Sunday. You can't come in, work super early. You can't stay super late. So again, that may not be a bad thing, but you could set those limitations on when those sessions can be established. Now, we also need to talk about identity as a service, IDaaS. And whenever you see the ID something AAS, you need to think cloud services like, PaaS, like a platform as a service, is a good example. But this is identity as a service. These are offerings that are in the cloud. Cloud-based services that broker your identity, and they help with your access management functions to target systems on customer premises in the cloud. So like your platform as a service. Maybe you use cloud services. You purchased something from a cloud provider, and you have a platform as a service up there. So now instead of having your infrastructure down here, your infrastructure's out there, if you will. It's in the cloud somewhere. So you could use these identities as a services to take care of this. Now, this is a combination of administration and account provisioning, authentication and authorization, and reporting functions all in one. So this is actually pretty nice, this identity as a service, because it helps you with your cloud-based services. And a lot of corporations and a lot of businesses are moving that direction. They're moving out into the cloud because they don't have to worry about stuff on the back end, right? Used to, if you wanted Microsoft Office in your enterprise, you'd have to go buy licenses for everybody, or a site license, and then you'd have to update it. And if a new version came out, you'd have to buy that and then blast that image out and then keep it updated and take care of it. If you do it in the cloud, all that is on the service provider now. You just use it, and you're paying for it. Don't get me wrong. It's like a lease on a car, right? You're paying for it as long as you're using it. And then when you don't need it anymore, you stop paying for it, and you terminate the agreement. But they take care of everything. They take care of the updates. They take care of new versions. They take care of any errors in the background. It's really nice, and corporations like that kind of thing. So, identity as a service. Now, we do have a couple different authorization mechanisms that we need to go over again. I'm sure you know these. I hope you know these. These are pretty fundamental in most security classes that you're going to take. But you have access control models like MAC, DAC, and RBAC. MAC, mandatory access control. DAC is our discretionary access control. RBAC is that role-based access control. And then we have another RBAC. I didn't put it in there as RBAC because sometimes it gets a little confusing, but that's rule-based access control. So let's look at mandatory access controls, the MAC. This is system-enforced access controls based on clearance on object labels. We talked about object labels before and the necessity for them. This is why. This is for what you're allowed to do. Well, you have this type of clearance. You can look and see, modify, whatever, this particular object. Now, subjects and objects have clearances and labels, respectively, such that confidential, secret, and top secret. When you think MAC, you need to think like the United States government, United States military. They use these type of labels like confidential, secret, and top secret. And things will be labeled that. You hear that on the news all the time. Well, the president has classified this as top secret. Right? So now it's at one of the highest levels that we have. So if you don't have a top secret clearance, there's no way you're going to be able to see or get that data. And even at that, you may not be able to get it. So a subject may access an object only if the subject's clearance is equal to or greater than that of the object's label. So if it's labeled secret, anybody with a secret clearance is good. Anybody with a top secret clearance is good because they're up here. Now, subjects, however, let me clarify this a little bit. Subjects cannot share objects with other subjects who lack the proper clearance or write down objects to lower classification labels. So even though I said top secret can access this, they can't write down to it, right? They can see it, read it, but no write down. MAC systems are usually focused on preserving the confidentiality of that particular data. All right, so that's another key point that you want to file away in the back if you didn't have that one there already. Discretionary access control. This gives full control of objects that have been given access to, including sharing the objects with other subjects. So the subjects now are empowered. The subjects have the control. You and me, we have the control, and we control our data. Now, standard Unix, Linux boxes, and Windows operating systems, we use DAC for file systems. The subjects can grant other subjects access to their files, change their attributes of what's going on in the system, alter them, or just get rid of them altogether. You are in control of that. The Windows file system, like I said, is a prime example of this. You get in and you create some data, all right? You open up a text editor and you write a dissertation. That's yours, right? You control who has access to that. If somebody else has an account on that computer, you can grant them or deny them rights from accessing that document that you just created. It's at your discretion. That's what makes it a discretionary access control. Now we also have role-based access control. This defines how information is accessed on a system based on the role of the subject, you and me. You know, what role do we hold inside of this organization or inside of this enterprise? So a role could be, say, a nurse, a backup administrator, the help desk technician, the administrator, the security professional, the CEO, the custodial staff, the administrative assistant, etc. Tons of examples. Those could all be roles inside of the organization. Now, subjects are grouped into roles, and each defined role has access permissions based upon the role, not the individual, which is even better for system and security professionals and admins. Let's say we have 1,000 users. 500 of those have the same job function, right? They're all help desk technicians. Let's say we're customer support for somebody. We're all help desk technicians. Instead of you, as a system admin or security admin, instead of you going to each individual account and giving permissions to all 500, you say, okay, you all have the same role in the company. We're going to create a role. We're going to apply the permissions to that group. Now I'm going to take all of these accounts and shove them into that group. So now I'm applying permissions in one area, and everybody that gets put in that group, they inherit those permissions based on the roles that I gave them. So that's the role-based access control. I'm saying this group has this type of access due to their role. And everybody that gets shoved into that group, they inherit those permissions. Now, this is a type of non-discretionary access control because those users, they have no control over what permissions they get or don't get. Because I'm taking their accounts and I'm putting them into a group, and that group already has permissions assigned to them, so it's not at their discretion anymore. They're kind of doing what they're told because we're getting drug over here and drug over there. So that's non-discretionary. So about non-discretionary access control, task-based access control is another non-discretionary access control. It's kind of related to RBAC. Task-based access control is based on tasks each subject must perform, like writing prescriptions, restoring data from the backup tape, or opening the help desk ticket. Goes along with those examples from earlier, the nurse, the backup administrator, and the help desk technician. What it does, it attempts to solve the same problem that RBAC solves, the role-based access control, focusing on specific tasks now instead of generalized roles. Because yes, you all may be generalized role, but some of them may have more specific tasks. So that's where this non-discretionary access control of task-based access control comes into play. And then we have the rule-based access. A rule-based access control system uses a series of defined rules, restrictions, or filters for accessing objects within a system. It's kind of like the if-then statements, right? Well, if this meets this criteria, then do this. So if the IP address, destination, or source IP address equals this, then permit or deny. Because we use rule-based access a lot in firewalls, we have predefined approved content or not approved content. So we say, okay, if this is legit, then you're allowed. If it's not, then you're not allowed. So, if the user is authorized to surf the web and the site is on the approved list, then we're good. We're allowing access. But other sites might be prohibited. We're saying no, and this rule is enforced across all authenticated users. So this doesn't matter what type of role you have. It doesn't matter if you created the data. This is based on rules, and most of the time you see these in like ACLs for firewalls, proxies, and things like that. So they're allowing you, and they're making decisions, right? If something equals something, then do something. Allow it, deny it, prohibit it, something. So those are rule-based access. Now let's talk about some of these access control attacks. I said we were going to talk about some of them. We talked about brute force and dictionary attacks. Just to revisit that, brute force. I'm trying every possible combination. Letters, numbers, special characters, uppercase and lowercase. Everything. I'm trying to use everything I have to crack that password. Or better yet, crack a passphrase. Could be a PIN number too, but that one's not as bad because it's usually just numbers. Now, a dictionary attack, remember, is more focused, but it's a predefined word list. Things we can find in the dictionary. It's faster. It's a little bit more efficient, but it's not as successful as a brute force attack because a brute force attack is trying every possible combination. It's going to get there eventually. It may take 100 years, 1,000 years, but it will work. It's not efficient. I didn't say it was fast and efficient, but it is diligent. It will get the answer eventually. You may not be around to see it, but like I said, it's going to find it. So you can find words lists like dictionaries, foreign languages, special interest dictionaries. They're widely available on the internet. I mentioned that earlier. And then you're going to put those word lists in a password cracking utility, like John the Ripper or Loaf Crack. Right? They're out there. They're utilities that you can use for password recovery. That's how I'm going to phrase that. Now, attackers typically run these password cracking utilities against a copy of the target system or a copy of the network, their security account database, or password file. The utility creates hashes of the passwords contained in that dictionary or word list and then compares the hashes out. Remember those rainbow tables I talked about? That's where this could come in with a hybrid attack. So I compare these to these hashes. These are the hashes that I've acquired from your computer. Once I find a match, I can deduce what the password is. Another access control attack, man in the middle. Now, I don't have to be right in the middle. It doesn't have to be 50-50. So I have to be somewhere between the communication ends, right? So here an attacker intercepts messages between two parties, and what I can do is forward modified versions of the original message to the intended recipient. So I can fake the data. Now, I don't have to. I can sit in the middle and I can just watch the data, right? I can sniff the traffic as it's going across, and if it's not encrypted, guess what I'm getting? I'm getting lots of good data, good information. If you're using some type of encryption, it's not going to do me a lot of good. I'm going to have to come up with some other type of attack to try to get this. So I could do that. I could do a type of man-in-the-middle attack, session hijack. We're going to talk about that here in just a second. I could do some spoofing as a man-in-the-middle attack. I could spoof your MAC address. I could spoof your IP address, try to disassociate you with the server. Maybe it will talk to me. Different types of things. Usually the man-in-the-middle is I could just sniff traffic is a pretty generalized one. I could also have it where I can be a man-in-the-middle attack, be sitting there between you and the server, let's say, and I'd have to be on your network to make this happen, by the way. You can't. This doesn't really work across the web. But sitting there, and you're passing traffic back and forth to the server. Well, now I'm sitting there and I'm sniffing traffic. Well, I could spoof credentials and identities and now get you to talk to me while I'm talking to the server for you. I'm acting as like a proxy. But all the while, I'm just seeing the traffic going back and forth because now I'm the one passing it on back and forth. And you're not going to know, right? Because you're supposed to send it to me. I set it up maybe as a gateway. So I set myself up as your gateway because I'm on your network. And so you're going through me, and now I'm passing it on to the server on the internet somewhere. It's going to talk back to me, and then I'll talk back to you. But all the while, I'm sniffing that traffic. I'm getting that data. So that goes along with packet sniffing, right? I can use some type of application, a sniffer, a protocol analyzer. There's a couple of them out. Wireshark's a very popular one. But I can use that to see the traffic go across the wire. And there are all kinds of packet sniffers out there as well. We could have a buffer or stack overflow. Now, if we do this, we could create a denial of service attack. We can also run arbitrary code, malicious code, if I could get it in there. So you might hear this as a buffer overflow, a stack overflow. You might hear it called smashing the stack. And it occurs because you only have so much space, memory space, to run an application, right? There's only so much in that register that you're allowed, right? And when you go over your allocation, it overflows. Kind of like if you took a cup and you started pouring water in there, right? It can only hold so much data, so much water. But if you pour more in than it can hold, it overflows. Well, those causes an exception inside of computers. Those cause errors. And if we don't trap for those errors, we don't trap for those exceptions properly, then what could happen is when you get, because it's actually at the bottom, when you get to the bottom, it smashes the stack and it will cause a buffer overflow, and now we could run malicious code, something that we put in there to make it run, open up a back door. go download a Trojan horse or run something that we need it to run. Now, a teardrop attack is a type of Stack Overflow attack, and it exploits vulnerabilities in the IP protocol, not necessarily an application like what I was describing. So the best defense against buffer or Stack Overflow is to identify and patch your vulnerabilities. Vulnerability scans, penetration testing, fuzzing your applications is a great way to protect yourself. Now, session hijacking, it is a type of man-in-the-middle attack, like I mentioned earlier, but now I am hijacking your session. Remember that session management we talked about? And I said you had a session ID? If I can get that session ID and replay that to the server, it's going to start communicating with me because it thinks, oh, well, you're over here, so I'm going to start talking to you. Now, when I do that, right, I'm going to try to start communicating with the server. I need to kick you off somehow. I need to terminate your connection, so now it will just talk to me. So I can hijack that session. I can get that from the cookie, right? If they put the session ID up in the URL, which is not great, I can get it from there with those packet sniffers that we talked about just a second ago. So it all kind of works all together. And then probably my favorite is social engineering. Now, this is pretty low tech, and maybe that's why I like it. I consider myself kind of a technical person, but you don't need a lot of tech skills to do social engineering. You need to be able to think on your feet, be pretty personable, but this is very effective and very easily carried out. You're not always successful. If you don't walk the walk and talk the talk, you may be made fairly quickly. Now, what I'm talking about is maybe I could come up to you and say, hey, I am the new tech guy, and we're resetting passwords. Can I get your old password and username, and so I can make sure yours got reset? And act like I got a checklist here. I may, have a badge, fake badge on or whatever. If it's a large company, maybe, he maybe is a tech guy. I've seen people just flat out ask, just like that. Right? You see that on movies all the time, right? What was that old movie? Hackers, right? Where he called up the telephone guy, or he called the guy up on the telephone, the security guard there inside the television network television station there, because he wanted to watch something on TV. And he said, hey, there's a box sitting right there. Can you give me the number on the bottom of that? So he's asking him for the modem, right? Remember that remote access we talked about before? He asked him for the modem, so he was trying to hack the modem so he could make the computer go get the tape that he wanted to watch, because what was on TV just wasn't doing it for him. So that's kind of neat, right? But he just called him up and asked him for it. He's like, hey, this is such and such from over here from tech support. We're having some problems. Would you mind picking up that box there on the floor or on the ground or on the table? And he would, they talked to him for a second. He said, yeah, I need that number on the back. Well, that guy didn't ask him any questions. The security guard didn't. He just went ahead and gave him the information, and all was good. But that's social engineering. And there's other forms of social engineering. I mean, you might not just flat out ask somebody like that, impersonating somebody. You may ask them over the phone. You call them up, ask like your tech support, and ask. Be like, yep, this is Mark over in tech support. We're in building 3, and we had a breach. I want to make sure everybody's okay. Can you give me your username and password real quick so I can check your account? They might just give your username and password right over the phone. They shouldn't, but they may. You can do dumpster diving, right? You can look for stuff in the trash. Not the best idea, all right? Depending on whose dumpster you're diving in, could be against the law and where it is and things like that. Different states are different regulations. But for the most part, don't go jump in the big dumpster out back behind the hospital or anything like that and try to look for, confidential information. You're going to get in trouble for that one. But it is a form of social engineering. All right. Now, there is no law saying you can't put your cell phone camera in there and start taking pictures of things that might be laying out in the bottom. All right. That's not necessarily against the law. Looking is not against the law. Taking is, or being in there is. So, I'm not going to get into a legal debate, but it is a type of social engineering. Shoulder surfing, type of social engineering. It's pretty easy to do. I mentioned that earlier when I was talking about airplanes. I think I mentioned that in domain 1 as well. You're sitting at an airport. People use computers all the time, right? You're walking by, you can just see it, right? You don't have to be right over their shoulder. I mean, if you're just looking from afar, you're shoulder surfing. If you're sitting beside somebody on an airplane, you're usually sitting pretty close. I don't, fly first class all that often. You got more of a buffer between somebody, so you got that one little armrest, right? If they're on a laptop, they're this far away. You could look over, right? That's shoulder surfing. Raiding cubicles. You're looking for passwords on monitors, under the keyboards, under mouse pads. Sometimes you don't have to raid it. You just walk by and you see it on their monitor. Not best practice. They're obviously not following our security policies, but it happens. And then, like I said, plain asking, right? You can just pretend you're somebody and ask for that information. Social engineering is great if you get good with it. If you can, again, walk the walk and talk the talk. If you can dress the part, if you can look like you're supposed to be there, act like you're supposed to be there, you know how to talk to people, you can think on your feet, you could probably pull off some social engineering pretty easily. And then the access provisioning lifecycle. So once the proper access control model has been chosen, once we figured out what we want to do, and we go ahead and deploy it, we put it out in our organization, the access provisioning lifecycle needs to be maintained and secured. So we pick what we want, we put it into action, now maintain it. Make sure that we are doing what we're supposed to be doing. We're supposed to be doing our due care, using the proper access control model. Now, many organizations follow best practices for issuing access, control access, but lack formal process for ensuring that the entire life cycle or lifetime of access is kept secure as employers and contractors move through the organization. So if we have contractors and vendors and whatnot come into our organization and they're temporary, they may be there for 30 days, 2 weeks. Make sure we have that life cycle that goes through those accounts and say, wait a minute, they haven't worked here for 6 months. Why is their account still active? Somebody's not doing what they're supposed to be doing. So we have to make sure we go through that. We need best practices. We need some policies in place that say, well, after 24 hours of being out of here, their account needs to be disabled. So we'll give whoever it is a day to deprovision that account. So that's what provisioning lifecycle is. Make sure we're maintaining and securing our access control model that we pick. Now that does it for domain 5. All right, lots of information in there. We talked about controlling access to our assets, identification and authentication, identity as a service, remember those cloud identities, third-party identity services like the Kerberos, authorization mechanisms, access control attacks, and then finally managing the identity and access provisioning lifecycle.